This video is going to show you how to use the chain rule to find the derivative of a function that is a composite function. The first thing you need to do is to be able to recognize the inner function and the outer function from what is given to you. So first of all, they've defined f of x as the composition of f of g of x. When I look at this, I see an outer function and an inner function. The outer function is f of x. The inner function is g of x. So I've made a little chart over here, and I'm just going to put in that chart what I'm identifying as the inner function, what I'm identifying as the outer function. We have to take the derivative of the outer function and the inner function. Now, the derivative itself says f prime of x is the derivative of the outer function composed with the inner function multiplied by the derivative of the inner function. Okay, so in my little picture here, here's my f prime of g of x. So once I get the f prime derivative, I have to put the g of x function back inside it. Then I multiply by the derivative of g of x. Okay, let's try some examples. We'll see if we can get through all 6 in under 13 minutes. So, taking a look at question 1, we're supposed to find the derivative of the square root of 5x squared plus 3. What is your outer function? What is your inner function? I'm going to make a chart just like I have over here. I'm going to identify the inner function as 5x squared plus 3. I'm going to identify the outer function as the square root of x. I'm going to take the derivative of each of those functions. F prime of x. Remember, we need to think about this as x to the 1/2 power. So that'd be 1/2 x to the negative 1/2. Perhaps you are becoming more fluent with this, and you can go directly to 1/2 root x as its derivative. G of x is just a polynomial, so g prime of x. We use the power rule, and we get 10x. Now let's put it together. F prime of x should equal the derivative of f composed with g of x times g prime of x. Okay, so I start with my derivative of f of x, which is 1/2 root something. What goes inside that square root is g of x, the original g of x function. Then I multiply by g prime of x, which is 10x. And I would probably just put this in the numerator. And if at all possible, let's reduce by a factor of 2. So our final answer is 5x over the square root of 5x squared plus 3. Okay, question 1 done. Let's take a look at question 2. Question 2, y equals 1 over the quantity 1 minus 3x squared cubed. What would you identify as your outer function? I would say 1 over x cubed. Our inner function, g of x, what is being cubed in that denominator? 1 minus 3x squared. Take the derivative of each. So again, g of x just requires the power rule. That's a negative 6x. But f of x, I'm going to think of f of x as x to the negative 3. And now f prime of x is negative 3, x to the negative 4, which I'll write as negative 3 over x to the 4th. All right, let's put this together. The derivative of y with respect to x will be the derivative of the outer function So let's write that down as a nice template. Negative 3 over something to the fourth power. What something? G of x. Then I multiply by the derivative of g of x. Simplifying all this, combining like terms, whatever we can do here, this is going to become a positive 18x in the numerator over 1 minus 3x squared to the fourth power. Okay, next up, number 3. We need to identify our inner function and our outer function. Let's see, we have a quantity to the thousandths power. F of x is x to the 1,000. What is g of x, my inner function? X to the 5th minus 1. Okay, I need the derivative of both. Both of these just require a power rule. 5x to the 4th for g prime of x. 1,000 x to the 999 for f prime of x. Do you see why it's important to label everything so we don't get confused about what we're talking about? F or g, f prime or g prime? Let's find our derivative. dy dx is equal to the derivative of the outer function composed with the inner function times the derivative of the inner function. Simplifying, I'm just going to move this 5x to the 4th in front and call this 5,000 x to the 4th, x quantity x to the 5th minus 1 raised to the 999. Okie dokie, moving on. Alright, number 4 is looking a little messier, but maybe it's just a little bit like number 2. We have 1 over something to the 1/3 power. So our outer function, f of x, is 1 over the cube root of x. I'll write that as x to the negative 1/3. Our g of x, the inner function, is x squared plus x plus 1. Take the derivative of the inner function, we get 2x plus 1. The derivative of f prime of x will be negative 1/3 x to the, what is negative 1/3 minus 1? Negative 4/3. I'm going to write that as negative 1 over 3. And you can either leave it as x to the 4/3, or you could write it as a cube root of x to the 4th. Probably just as easy to leave it as the rational exponent. Okay, let's compose our function. F prime of x is equal to negative 1 over 3 something to the 4/3 power. We compose that derivative with the inner g of x function, and we multiply by that inner function's derivative. Simplifying, I would just leave it as negative 1 times the quantity 2x plus 1. Make sure you have those parentheses or the answer is not correct. 3 and x squared plus 1, x squared plus x plus 1 to the 4/3 is in the denominator. All right. Okay, number 5. What is the outer function, f of x? Well, it looks like we just have something to the 5th power, so I'm just going to call it x to the 5th power. The inner function, g of x, is x minus 7 over 2x plus 1. All right, outer function derivative is pretty straightforward. We should be pretty good with the power rule, so 5x to the 4th. But the inner function, how do I take the derivative of a quotient? I must do the quotient rule. So the quotient rule says, I'm going to identify these guys as f and g. So I need f prime times g minus f g prime all over g squared. All right, so let's do that. In a previous class, I also set up f and g and f prime and g prime. We could do that here, call this x minus 7, 2x plus 1. What's the derivative? It's just 1. What's the derivative? It's just 2. All right, so if I need this quotient rule, I need this product minus this product in the numerator. So let's take a look. We're going to have 1 times 2x plus 1 minus 2 times x minus 7 all over 2x plus 1 squared. Okay, simplify the numerator. That's just a linear expression on the numerator. We're going to get 2x plus 1 minus 2x plus 14 and the 2x's drop, and we're left with 15 over 2x plus 1 squared. Okay, I'm going to clean up some of this space here, and I'm just going to say the derivative of my g of x function, the quotient, turned out to be a nice and simple rational expression, 15 over 2x plus 1 squared. Okay, let's find the derivative of our composition, quotient to the 5th power. So I start with g prime of t is equal to 5 something to the 4th power. What goes inside here? The g of x function. And then I multiply by 15 over 2x plus 1 squared. Okay, a little simplification can happen here. Think of what's in your numerator, 5 times 15, and x minus 7 to the 4th. What's in your denominator? 2x plus 1 to the 4th, that's coming from this, times 2x plus 1 squared. So if we simplify, I believe we get 75, x minus 7 to the 4th, over 2x plus 1 to the 6th power. Looks pretty clean. Okay, last one. Okay, we have two functions being multiplied together. So we have to do the product rule, but within each product, within each factor, we have a composition. So here we have an inner function with a derivative of 2, but we have an outer function of x to the 5th. Then we have another function. Outer function is x to the 4th. Inner function, is x cubed minus x plus 1. So derivative of inner is 3x squared minus 1. Derivative of outer is 4x cubed. Okay, I'm probably going to run out of time here, but we're going to try our best. We also need to do the product rule. So we need f, which is this function, prime times g plus f times g prime. So I'm calling the first function f and the second function g, and now I have to take the derivatives. Run out of time. Take a look at the answers on the website and see how you do. Bye.